The Spanish crown was nearing bankruptcy. The War of the Spanish Succession had drained the imperial treasury, leaving the state desperate for an immediate infusion of capital to maintain its geopolitical hold. The answer to this economic crisis lay in the Americas, locked inside heavily timbered galleons and reinforced merchant vessels carrying treasure and cargo estimated in contemporary accounts at roughly 14 to 15 million pesos. But the crown's fiscal system still imposed a severe toll known as the Royal Fifth, a 1/5 claim on registered precious metals and other taxable colonial wealth. That mandate made the treasure painfully bureaucratic. Silver, gold, and private cargo had to be recorded, taxed, and guarded before departure. But the larger operational trap was the war-torn Atlantic itself. Years of conflict, privateering threats, and accumulated cargo forced the two Spanish treasure fleets to combine in Havana for mutual protection. 11 Spanish ships, joined by the French ship Griffin, were ordered to transport the staggering weight across the Atlantic. The delayed departure window became a strict operational trap. By the time the vessels were fully loaded, provisioned, and cleared through the required accounting, the calendar had slipped deep into the summer. It was late July. Every experienced mariner in Havana understood the Atlantic weather patterns. The late summer months guaranteed lethal atmospheric volatility off the coast of Florida. This coastline was an unavoidable geographic choke point for any fleet relying on the powerful northbound current of the Gulf Stream to carry them back to Europe. The navigation of the era required sailing parallel to a long, dangerous lee shore. Waiting for the safer winter months meant risking complete economic collapse in Spain, while sailing immediately meant challenging the highest risk weather window of the year. Strategic necessity overruled meteorological caution. The fleet commanders accepted the calculated risk. On or about July 24, 1715, the combined treasure fleet weighed anchor and left the harbor, sailing directly into the path of a developing Atlantic hurricane. The physical realities of the ships themselves severely limited their options. These were not agile vessels. The fleet was comprised of heavily armed galleons, merchant vessels, pataches, and at least one urca, the storeship Urca de Lima. They were designed for transatlantic endurance and mass cargo capacity, built with thick, heavy timbers capable of withstanding the immense concentrated weight of boxed silver and raw bullion. When fully loaded, they sat deep in the water, requiring substantial wind to move and requiring vast amounts of time and sea room to change direction. For 7 days, the convoy pushed north, maintaining a tight formation as they rode the current off the Florida coast. The single French escort, operating under slightly different tactical parameters, positioned itself further offshore. This minor geometric deviation in their sailing line would soon dictate survival. As the 11 Spanish ships tracked closer to the coastline, the atmospheric pressure plummeted. A massive cyclonic system, moving westward across the Atlantic, intercepted the slow-moving convoy. The high, heavy superstructures and fully loaded hulls gave the storm more leverage, but the decisive problem was now geographic. The wind physics trapped them. The storm did not simply scatter the ships in the open ocean. It drove them with absolute, unrelenting mechanical force westward, pushing them completely out of the navigable deep water channel and directly toward the shallow coastal reefs. At that distance from shore, the Spanish commanders could neither claw back offshore nor trust heavy anchors to hold against the cyclonic surge. One by one, the massive wooden hulls were slammed into the submerged rocks and sandbars of the Florida coast. The structural failure was immediate and absolute. Heavily reinforced lower hulls, built to carry immense loads of metal across oceans, were completely shattered by the kinetic transfer of deep water wave energy, breaking into shallow coastal zones. In a matter of hours, the 11 Spanish vessels were wrecked or lost as seaworthy ships. The French ship Griffin, holding farther offshore, slipped past the lethal wall of the storm and survived. For the Spanish, the human and structural cost was catastrophic. Out of the roughly 2,500 sailors, soldiers, and passengers aboard the fleet, more than 1,000 perished in the pounding surf and the chaotic immediate aftermath. The survivors found themselves stranded on a desolate, hostile coastline, surrounded by the splintered remains of an imperial fortune. The state had gambled everything on speed and lost the entire convoy to a predictable seasonal hazard. The documented cargo lost to the sea was officially recorded at 14 million pesos. Yet the immense pressure of the Royal Fifth had driven merchants to exploit every possible shadow in the cargo holds. If the official manifest declared 14 million, exactly how much unregistered wealth was hidden aboard to evade the very tax that doomed them? That same coastline also explains why so little recognizable structure survived. In deeper, less energetic water, a wreck may retain parts of its hull under the right conditions of temperature, oxygen, sediment, and biology. The galleons of 1715 were instead driven into shallow coastal energy, where hurricane swells compressed against the shelf and repeatedly hammered the ships into jagged reefs. Once trapped in that shallow surf, each galleon became a rigid system of heavy timbers and iron fastenings under extreme torsion. The concentrated weight of silver bullion and cast iron cannons worked like an internal hammer against the outer hull planks. Each impact against the seabed fractured the framing further, scattering coins, ballast, guns, and timbers into turbulent coastal water, where the debris could be buried, exposed, and buried again by shifting sand. The Spanish salvage response was immediate and driven by absolute state necessity. The crushing financial deficit that had originally imposed the Royal Fifth tax remained unresolved, and abandoning the wealth in the shallows was not an option. Authorities quickly mobilized a fortified salvage camp on the barren beaches directly adjacent to the wreck sites. They relied on organized salvage crews and divers sent from Spanish centers such as Havana and St. Augustine. Men forced to work inside dangerous, jagged debris fields where every descent was limited by breath, current, and surf. Within months, these crews began pulling silver, gold, and cargo out of the shallow wreck sites, recovering a significant portion of the Crown's treasure and private wealth. Later attempts continued for years, but the recovery was never complete. Much of the fleet's cargo remained buried, scattered, or simply beyond reach. But the shallow depth that allowed this manual recovery also created a severe tactical vulnerability. The Florida coastline was a primary transit lane heavily monitored by hostile privateers and organized pirate factions. Any surviving hull timbers still protruding above the rolling waves served as highly visible navigational markers, pointing scavengers directly toward the remaining unrecovered wealth trapped tightly beneath the sand and heavy lower wreckage. Spanish authorities did take one drastic step on at least one wreck. After Urca de Lima had been stripped of cargo, she was reportedly burned to the waterline to keep English pirates from using the visible wreck as a target. But the evidence supports that action for Urca de Lima, not as a proven fleet-wide burning order. The broader erasure of the wrecks came from storm damage, salvage, corrosion, and the constant movement of coastal sand. The fleet was systematically erased from the visual horizon, with visible markers stripped away by salvage, storm damage, corrosion, sand movement, and at least one documented burning. How could anyone find a vanished fleet under centuries of shifting sand? The physical evidence left on the modern Florida shoreline did not look like colonial treasure. It looked like completely ordinary, flat black rocks. Seasonal storms occasionally cut into the submerged debris fields and threw small anomalies onto the coastal sand. For generations, casual observers simply ignored them. But in the mid-20th century, a local builder named Kip Wagner recognized a distinct material contradiction. These blackened shapes washing up on the beaches were strangely heavy and possessed a completely unnatural internal geometry. When the thick, dark corrosion was carefully removed, the mundane flat black rocks were revealed to be Spanish silver reals. The discovery of the oxidized beach coins confirmed that at least one wrecked galleon lay somewhere offshore. But finding the exact source of the scatter in the open ocean was an impossible visual task. Sweeping the coastline by sight yielded nothing useful. Wagner realized that randomly dragging the ocean floor without a firm geographic anchor was a waste of time. To pinpoint the invisible seabed target, he had to leave the water entirely and hunt through the historical record. Wagner adopted a disciplined search method that relied on documents as much as beach luck. But the archival hunt was not Wagner's work alone. Within the Real Eight Circle, Kip, Kelso, and other researchers helped pursue documentary leads, numismatic evidence, maps, and older accounts that could connect the beach scatter to wreck positions offshore. One crucial lead came from the 18th century work of Bernard Romans, whose map and coastal notes pointed searchers toward the Sebastian area and the old wreck traditions tied to the 1715 disaster. The salvage challenge now became a matter of patient cross-checking. Archival leads had to be tested against the modern coastline, the places where blackened coins washed ashore, and the physical targets detected offshore. Wagner and the Real 8 team narrowed the search by matching old references with beach finds, local geography, and metal signatures on the seabed. The method did not mathematically isolate the fleet, but it transformed a blind coastal hunt into a focused search. But knowing the coordinates was only a theoretical victory. The actual remnants of the galleons and their cargo remained completely locked beneath thousands of tons of heavy, densely packed ocean sand. Archival geometry could point to a precise location on the map, but how could salvage engineers physically punch through massive layers of dynamic marine sand to reach a fragile target without destroying the evidence? The solution to the heavy sand barrier was not delicate excavation, but the deliberate redirection of mechanical force using a device known as a prop wash deflector. The search grid now pointed to a rigid bedrock shelf buried beneath deep layers of highly dynamic coastal sand. This sand was densely packed, saturated with seawater, and constantly shifting with the tidal currents. Manual labor, standard suction hoses, and conventional diving could not move that volume of overburden faster than the ocean replaced it. Industrial bucket dredges could rapidly remove the material, but heavy machinery would indiscriminately crush fragile historical artifacts and blindly scatter the dense silver riels across the reef. To bridge this mechanical gap, Kip Wagner established a dedicated salvage outfit known as the Real 8 Company. The team needed an industrial-scale force powerful enough to hold back the ocean, yet controlled enough to leave the submerged evidence intact. Their answer was an improvised piece of engineering that relied on fluid dynamics rather than heavy mechanical teeth. The salvage engineers fabricated a large, angled metallic duct and secured it directly over the stern propeller of their recovery vessel. This heavy tube was designed to pivot downward, essentially capping the horizontal thrust of the spinning blades. Before engaging the system, the recovery boat was locked into a rigid multi-point mooring setup over the designated target area. The heavy mooring lines required precise geometric tension to hold the hull absolutely stationary against the immense forces about to be generated. If the anchors dragged even slightly, the trench would wander off target and potentially bury the exact area they were trying to expose. Once the vessel was locked tight, the deflector was lowered vertically into the water column and the boat engines were throttled up. Instead of driving the hull forward, the deflector channeled the kinetic energy of the propeller straight down toward the ocean floor. This mechanism generated a massive, continuous column of fast-moving water. When this artificial vertical current impacted the seabed, it did not drill a narrow, destructive hole. The hydrodynamic force struck the bottom and radiated outward in a wide circular pattern. This controlled radial flow gently peeled the heavy sand away layer by layer, carrying the abrasive particulate up into the surrounding tidal drift. Because precious metals like gold and silver are far denser than the surrounding sand, they tended to remain closer to the underlying rock as the lighter sediment moved away. But the wash was not invisible to the sight. It could expose artifacts quickly, and it could also disturb fragile context if the work was not mapped, controlled, and recorded. Its operational value came from keeping a temporary crater open long enough for divers to work. Under the right conditions, the downward thrust could hold back the shifting dunes and briefly improve visibility near the exposed bottom. If the current, engine power, or mooring geometry shifted, it could also throw up a blinding sandstorm. Divers still had to work by hand, carefully lifting newly uncovered coins, guns, and fragments from an environment that could change in seconds. The invention of the blower transformed an impossible geological barrier into a systematic extraction process. The Real 8 Company now had direct physical access to the wealth that had eluded recovery for centuries. But once high-value colonial silver came off the ocean floor, the operation entered Florida's strict sovereign waters. Because the galleon hulls shattered and dispersed their vast cargo directly into these regulated coastal zones, modern marine engineers do not have free rein to simply strip the ocean floor. The contemporary salvage apparatus sits at the intersection of federal admiralty custody, exclusive court-recognized salvage rights, Florida state permits, state ownership rules, and archaeological oversight. The Admiralty Court assigns specific, geographically bound legal leases to a single recognized custodial entity. This legal mandate grants the approved salvors the exclusive right to search and excavate the highly contested ocean grids, but it completely eliminates the traditional maritime concept of finders keepers. The recovery teams must rigorously map, tag, and document every single piece of silver, every gold chain, and every shattered ceramic shard they pull from the Atlantic sand. This precise administrative chain of custody is a rigid legal boundary designed to prevent untracked commercial looting and to preserve a permanent forensic baseline of the scattered colonial wreckage. The ultimate constraint on the recovered wealth operates as a modern echo of the very imperial taxation that shadowed the fleet. Under Florida's current rules, recovered archaeological materials are generally divided so the permit holder receives approximately 80%, while the state retains approximately 20%. That division is negotiated with attention to historical and scientific value, allowing state archaeologists to preserve significant pieces for public interpretation and long-term research. Modern salvage operators still bear the expedition's financial burden, funding the heavy equipment and enduring the extreme physical hazard of the 120-day operational sprint under that same regulated division. This highly regulated framework of mechanized recovery and rigid legal compliance has successfully yielded millions of dollars in verified artifact retrievals. Yet these extractions have largely occurred within the tightly defined debris fields of the wrecks located decades ago, while several wrecks, possibly 5 depending on how the scattered sites are attributed and identified, remain unconfirmed or unlocated in any definitive modern sense. Centuries of shifting sand, storm damage, and chaotic coastal dispersal have made the wreck map provisional rather than final. The missing or uncertain sites mark a hard limit on what the modern recovery effort can prove. Even for the wrecks that have been successfully found, the evidence ceiling is sharply limited. Marine archaeologists can map debris fields, guns, ballast, surviving timbers, and artifact scatters, but a complete structural reconstruction of any vessel is unlikely. Some partial architecture survives at sites such as Urca de Lima. The full architecture of the fleet does not. This structural obliteration also prevents the economic mystery from being closed. The recorded value of roughly 14 to 15 million pesos established only a baseline for declared treasure and cargo. Any underreported wealth, whether concealed, disguised, or carried as personal effects, sits outside what the surviving paperwork can measure. That gap leaves the total financial value of the cargo that plunged into the surf unquantifiable. The modern salvage operation remains an undeniable partial success, with millions in colonial currency mapped, recovered, and secured under rigid legal custodianship. Yet the mission can never be formally completed against the physical boundaries of a dynamic ocean and the intentional blind spots of 18th century tax evasion. The surviving physical evidence leaves a fragmented portrait of a desperate empire stretched beyond its operational limits. Will those shifting sands eventually reveal the remaining uncertain wrecks, or will the full scale of what was never recorded in 1715 remain permanently unknown?